And we're live.
All right.
Super exciting. So I am hearing that kind of echo thing, and if it does keep going, we may need to like mess with headphones or something, but I'll play by ear.
I'm turning you down a little bit because you're a bit loud here.
Okay. And then I will go over here and I will make it live on the site. I get used to Damien just telling me what to do. When Damien and Hanselman are gone, I just don't know what to do. Okay. Now let's see about this.
See it live. So
good. Okay. And we already have 21 people watching, which is plenty in my book. So book, I guess it would be in my book. So welcome. This is exciting.
Yeah.
So Andrew, you've been on before. Why don't you introduce your friend there?
Yeah. So I'm Andrew Stanton-Nurse. I've been on a couple times, engineer on the team, but I have with me Dylan Gray, who is our intern for the summer.
Hi, I'm Dylan.
He's been working on SignalR, so this is his last week actually. So yeah, we figured it's time to show off what he's been working on.
Cool. So what was your kind of experience before you joined? Had you done .NET development? Were you experienced with SignalR at all?
I had done sort of like at school. Our school does like partnerships with different companies, and so I'd done like part-time through the year a project with Microsoft Dynamics, and so that was all. It wasn't like SignalR like ASP.NET development, but it was like C# and it was in Visual Studio.
Okay,
and
cool.
So like that helped me understand a lot of the fundamentals coming in, I think.
You know, I think that's one of the features of .NET that is pretty cool is you can like you learn .NET and then you can write a game, you can write a web server, you can write a desktop app. Like it's pretty portable, which is cool.
Yeah.
Nice. All right. Well, let me jump in and share the community links, and then we can get to the fun demo stuff, and you can show us what you've been working on. So let's start with this, and I will lock to my screen. Boom. So I'll start with Damien tweeted this, I think, just earlier today. I thought this was kind of neat. So there was a little bit of a mention of what was going on with what is it called? Dispatcher. Global routing and dispatcher. So this is neat. These he linked over to the benchmarks. Here you can see that they're kind of tiny. It's a little hard to see. Fortunately, when we go over here, they have you can see them gigantic. So and look at this cool spike here. So I thought that was pretty neat.
Yeah.
So and then from what Damien said in the thread there, it's it's internal detail in 2.2 and available everywhere in 3.0.
Yeah, I think there's some rearranging of things that needs to happen to make it available for everyone. So that's sort of why the staged rollout. We've done similar things with pipelines and other stuff like that.
So what's Damien talks really fast. I don't understand the guy. What is this? What's happening here that I get this big performance boost? Is there a simple explanation for simple people?
So to be perfectly honest, I don't know what's behind it.
Oh, good. All right, I feel better.
That's over. NBC figured out how to do that, and they did some profiling, I'm sure. So it might be something about the new architecture that makes it possible, but I'm not sure what's behind that specific increase.
Okay. All right. And Sebastian is saying in the chat there a new routing code base. So cool. Good stuff. Okay, so on to the next. This was something also Damien tweeted. This is the retweet Damien in a video show this week. So here, this is the early access downloads. I like that we've been doing this. These are all the, and there's caveats here about, watch out. And this is for advanced people like you are, if you're watching this show. So this is cool, though. This is where you can kind of try out the 2.1.3 release early access. So, and especially I would think this would be useful if you're building a library, if you're, the kind of thing where you've got dependencies and you want to like be ready when it comes out. You want to identify problems early and that kind of stuff.
Yeah, this goes back to the idea that in the early days of ASP.NET Core, when we were just packages, we shipped nightly builds onto MyGet, and you could download just literally yesterday's build and it would just work. When we have the shared framework and the SDK, things get a little more complicated, and we're trying to make it easier to get these early access downloads so that you can test out your libraries and components with them and make sure they'll still work.
Cool. All right. This is a really great post, I think, from Philip, and he goes through and talks about centralized exception handling and some things that I did not even know were a thing. He talks about there's this RFC for problem details that it's an HTTP problem details kind of a specification, and there's already a POCO that is set up for that. So these are all the kind of things where you can package something up as a problem details, and it has all these things you would probably want to say. And what's cool is this is all kind of following that RFC. So, you've got things like a title, details, status, etc. And then he goes through and does 2 instances talking about exception handling, talking about how to do exception handling using those problem details. And then he also talks about validation as well. So going through and doing validation and packaging those, taking advantage again of the problem details for your validation messages. So I thought that was pretty cool how it's an application, and I did not even know, number one, there's an RFC, and number two, that there's built-in support for it. So
yeah, it's kind of a spec for transmitting exceptions basically across a JSON protocol. It's cool.
All right, this is cool. This is from Red Hat, and they've gone through, and this is a post about using Linux-specific transport. So it talks about the transport abstraction, and obviously there are going to be things that are faster or different about different operating systems to give you the best transport. And so, kind of cutting to the chase here, there's talk about what exactly is going on with libuv and how they've optimized for it. They talk about, there's some benchmarks here about showing this off using the Linux transport. And so here they're saying the 20% improvement for JSON. And this is all that's required here is this in the build web host, just call it use Linux transport. And he points out there that it's a no op. If you use it on Windows, it's not going to break anything. So it's just pulling in this package and then calling, so it says Red Hat ASP.NET Core Server Kestrel Transport Linux, and then use Linux transport. So I thought that's really cool. It's nice to see Red Hat, they're a member of the .NET Foundation. They're engaged and involved in .NET development, and this is cool to see a usable thing here that they've built and are talking about here.
Yeah, it's kind of like with every abstraction, if you go around the abstraction, you can get some little bit of performance benefit, but you lose the portability. So it's cool to see them like build really optimized transports for their specific environment.
Mm-hmm. Yep. And this seems like, it's never going to break anything. It looks right. Pretty cool just to have there. So
yeah, everything's opt-in. Yeah.
Yep. Yeah. So this is kind of cool too. We've been calling out things from the PeachPy team. They're very active and building a lot of cool stuff. They had one thing that they tweeted about recently about building partials, rendering PHP with, rendering Razor partials in a PHP view. So that's pretty neat. But here they're talking about ASP.NET Core response caching. So usually with things like WordPress, it's very common to use some sort of response caching thing. There's all kinds of WordPress plugins for response caching. Here they're showing that that you can use response caching middleware and set that up directly here. They talk about WordPress specific behavior. What's interesting is I was immediately thinking, like, show me the benchmarks, and what they point out here, which kind of makes sense when I thought about it, is you're not going to see any. There's no point in benchmarking this because the entire point is it's cached, right? So, but the nice thing is that this is a simple implementation. This is very easy all across your app. You can just turn it on using this response caching middleware. And from when I've used WordPress before, it's been a little bit complicated to set some of those cache things up. So, all right, I'll try and speed up. There's a lot of good stuff today. This is neat. This is an expense manager using EF Core and high charts and ASP.NET Core as well. So I like this. It goes beyond the kind of hello world. This shows something where you're actually building out expenses. It's a real world kind of business application, and the charts are cool too. So this is all the code here as far as building out the model, implementing, hooking up, and all the kind of front end stuff too. Stuff there. GraphQL using .NET Boxed. So we've talked about .NET Boxed in the past, which is a cool open source project that has kind of a lot of stuff already kind of pre-cooked for you. And I like this. This is Eric taking a look at that and showing off how easy it is to do GraphQL using .NET Box. So here going through showing the schema and query and just kind of showing the implementation of it. So this is a very kind of quick walkthrough, and it's nice to show how simple that makes it. Okay, this one's interesting. I don't know, Andrew, you may have an opinion on this. This is about, I don't know if you saw this one. So there's already support, of course, in Razor. You can just do, @if. And so what Andrew Locke pointed out here was he wanted a tag helper version. And he liked the way it looked better. It worked better with his HTML parser, or it may work better in different IDEs and that kind of stuff. So he went through and did this if tag helper. Of course, not a whole lot of code there. It's pretty easy to do an if logic, and then showing that this is kind of the result here. And then alternative syntax is an attribute instead of an element.
That's really cool. Yeah, I think the whole thing it's fine. Like it's interesting to have different ways to do things. And I think tag helpers really allows that, which is cool.
Yeah. Okay. Cool. All right, Rick Strahl. Whenever we call out Rick Strahl, he writes beefy posts with a lot of information, some good opinions. So here he's talking about WebAssembly and Blazor, and this is, we've done a lot of stuff about Blazor lately. We had the team on and stuff, but I love the way that he kind of tears everything down, looks at, shows you, all the kind of what everything's built on, how it runs. There's a ton of information in here. Here it's good to see too here where he's looking at what's the kind of support levels that you can look at for WebAssembly and a lot of information. So you can see from the scroll bar there's a ton here. So take your time, grab a cup of coffee, have fun. This is one I'm calling out because I was gone last week. We didn't do the community links, but the Blazor 050 release is out. Some of the big things in here were already shown off in the recent community stand-up, server-side Blazor. Some things with like rendering of raw HTML. Some good stuff there.
Server-side Blazor powered by SignalR. Of course.
Yeah. Good stuff. Here's an interesting one. This is from, I'm going to pronounce his name wrong, so I've actually got it handy. This is Vaktanji, I believe. And so he's been doing a lot of cool stuff. And this one is, he previously did a clock for Blazor, but it was using Canvas. And in this case, here he's using SVG. So it's kind of fun to see because it's all web standard stuff, easy to, or possible to integrate with a lot of different things.
Cool.
Yep. Okay, almost done. Nate McMaster talking about plugins. He talks about the different ways that he introduces what the plugins are. He talks about why. So there's assembly load from, but there's a bunch of problems, mostly with dependency management, loading, locating, mismatches, race conditions, etc. He talks about assembly load context, which can solve those problems, but it's low level and you have to do some work. So then he talks about this plugin loader that he wrote. And he also, what's kind of cool is there's a demo app. This is ASP.NET Core, and it's got it's loading some plugins. So I've talked over the years to tons of people that are wanting to do different plugin, runtime loading of plugins. And this looks like a pretty neat implementation. And the last thing that I'm contractually obligated to point out every time I talk to anyone, including my neighbors, the mailman, etc., is .NET Conf. .NET Conf is coming up soon. We were just reviewing submissions for the presentations, community presentations, all kinds of good stuff. So this is coming up in 42 days. There's online stuff. There's and it's going to be followed by local events. So if you would like to do a local event, you can see already we're getting a bunch of them that are being submitted. Please let us know so we can send you swag so that we can, get you listed here and stuff. So if you would like to do a local event, then get in here and tell us about it. So this is at .netconf.net. And here endeth my commercial. And
cool.
Over to you.
All right. Yeah. So Dylan's been working with us for just about 3 months now. And he's been working on making some changes to SignalR, bringing in some new features that we've been talking about doing for a while. He's going to sort of talk a bit about what he's done, and we've got some demos we can run through, and then we can answer some questions about how it works and sort of what our plans are for it. I can tell you that the stuff we're working on right now is probably not going to happen in 2.2. We're looking a little further out than that, probably like 3.0. Yeah, I'll let Dylan sort of explain a little bit about what he's done.
Yeah, so most of what I've done, it's been, call it like streaming parameters. And what it lets you do is, so when you're on a client in SignalR and you want to call a function that's on the server, so before you could only pass in like stuff that you can JSONify, so you can pass in your numbers and your strings. And so what my feature lets you do is it lets you pass a channel reader through to the server. And so what you can do is you write a method on the server, and this takes a channel reader, and you invoke that method with the channel reader that you've made on the client. And then it does the invocation, and it goes into the method on the server. And then whenever you put anything into the channel on the client, it just comes out magically in the channel on the server.
Yeah, so this is using the new system.threading.channels API that was added in 2.1, I think. And it's basically, it's very familiar to Go, has a construct in the Go language for channels. And it's basically just a pipe. And objects go in one end with the writer, and objects come out the other end from the reader. And that sort of lets you just sort of have one side can have a writer, one side can have a reader. That all works in process with just the channels API. What Dylan's done with SignalR is let you effectively, when you invoke a method on the server, you can pass a channel through that, and you can sort of send items one at a time through that channel up to the server. Whereas before, if you want to send like a list of items, if you wanted to call a method on the server,
you'd have to squish them all together into one really big message and send it through.
Okay.
People, and that would like.
Right.
There was a lot of complaints about people going over the maximum payload set.
Yeah.
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 And
so
try and squeeze big things through, and it just didn't work.
Right. So, if you want to send a file, which is, maybe SignalR is not the most appropriate for sending files, but if you want to send a big chunk of data, you'd have to either send one giant message with a huge byte array, which could be very problematic, or you would have to manually implement some kind of chunking system and track that yourself. But now we've got a system where we're working on a system where you can actually handle that streaming, and we'll handle the sending chunks automatically for you.
Like the routing of chunks to the right streams.
Right. Yeah. Exactly.
That's something I wouldn't have thought of immediately, but the chunking is one thing, but then like you're saying, sending the chunks to the right places, if you've got multiple chunks flying all over the place, that's
right.
Confusing, right?
And so I noticed there's a question in the chat about would video streaming be possible? In theory, yes. This is the kind of thing that could allow that. Whether you should use SignalR for video streaming, I think is a different question, because there are a lot of really good video streaming protocols out there already. But it is that kind of thing, sending chunks of data across the wire. And it's not just for really big data, it could also be for data that appears over time. And so you could have inputs that the user is typing, for example, could be
live measurements from some sort of construction equipment or
right,
something.
Yeah, like measurement data, it's just about data that needs to come in sort of separate segments, right? That needs to come over time in segments. It could be one big piece of data, or it could be a bunch of little data that happens over time. And some of our examples can kind of show sort of what that looks like.
Cool.
So I will start sharing our screen.
Woo.
And I'll jump over to, I haven't done it yet. I hit the wrong button. That's the right button. share the screen. All right, so we should have something up. Let me, we'll just go straight into launch the demo, and I'll let Dylan kind of explain some of the code. We'll start with some of the JavaScript code on how you would invoke a method using this streaming. Are you seeing the screen, John?
I am.
Yep, it's up. All right, so this JavaScript code.
Yep.
Flip.
Just flip, get rid of that.
Oh, yeah. All right, so what this does, this is on the TypeScript client, sort of the TypeScript client, also the C# client.
So we got connection there, connection on line 105. That's a SignalR connection, just standard like you have today.
And this is an upload stream object, which is a new concept. And so you just make one from the connection. And then we want to send over the word zoop. And so what we do is for each, so we invoke the upload word method with this new stream. And then to send over the word, we send each character one at a time. And what the method on the server does, and we'll look at it in a little bit, is it takes all the incoming letters out of the channel and it appends them together. And then it just sends you back your word. And so we send each letter a bit of logging, and then we say, all right, we're done sending. We want a result back now. And then you await the invocation promise. And this is the server gets back to you and says, here's your word. And then we're done. So if we go over to the browser here.
Actually, yeah, just open up a new tab.
Localhost.
Localhost : 5000. That one.
This
Yep.
one.
Yeah, here we've got a page. Let's open up the network tab on the, so F12 can show a little bit of this. So if we go to the network tab and let's refresh the page, we connect. All right, so now we've got, so SignalR uses WebSockets, although it has a bunch of other transports. We can see the WebSocket is connected here. Right now you just got handshaking messages and we sending pings every once in a while. But now when Dylan clicks the zoop button, it will invoke that method and we'll see some frames appear over time. So let's do that.
So hit zoop.
And you'll see.
We see.
Yeah, you see it's sending here. You'll see the items coming in one at a time over, and I think the code had a 2-second delay between sending each. So we're sending each individual letter as a separate message. Yeah. And if we jump now over to VS, which is flashing.
Hit the breakpoint.
We hit the breakpoint. So we can show the server code a little bit. Server code's pretty simple. We've got just a standard hub method. Let's just scroll this a little bit so you can see the whole thing.
Point.
You can see the server method. It's taking in this channel reader of string, and we have a loop that's basically just saying read items out of this channel. This sort of double while loop pattern is a common pattern with channel reader because it lets you read synchronously as much as you can and then block to wait for new items.
Okay.
And you'll see it's broken on this breakpoint, and if we look at item, it'll say Z because that's the first item we get.
One, and we have 5.
And we keep getting O, and so on. We're getting all those items in a row now because the client has already sent them because we were broken in the debugger.
And then this will go through.
And then if we flip back to the browser, you'll see it says.
Wait, where'd it go?
Flip back to there.
Oh no.
Yeah, it's supposed to send the return value, but I think there might be a little bit of a bug there, but that's all right. We can, but the idea is the server can return its result. Oh, I think I know what happened. I think it timed out.
It timed out.
It timed out because of the bugger.
I will
be quicker.
Go through real quick. All right. Is it?
Yeah, the whole connection's broken.
The connection.
So just refresh the page. This is the thing about debuggers and like network stuff where there's timeouts. Is the debugger messes with the timeouts because you're stopping everything.
Yep.
Connected.
Now we flip to that breakpoint. We get 1, keep hitting F5. You'll notice there's a few seconds in between each because
we put a 2-second delay in.
Yeah.
I think every program needs a zoop button going forward. Coding standards.
And there we go. So now we see that it sent those messages 1 every 2 seconds, and we eventually received the result from the server, which is everything sort of concatenated together. So that kind of lets you, and that stream that you have that you can call write to is called write on. You can send any data you can send through SignalR today. Complex objects, binary data, you can send through those streams. And they just appear.
As long as you can serialize it in JSON.
As long as it can be serialized, yeah. So, yeah.
Wow.
We got another demo, which would be sending a file.
Practical examples.
Something a little more practical than sending the word zoop. First, let's shut down this server. So flip over to that one, and just close the window. Yeah, a bunch of, that's fine.
All right.
And let's restart it without debugging because we're going to do some console things.
So I gotta. Wait.
Yeah. Cool. So we've got the server running, and then all right, and so then we want to show the demo. So let's go to
snap the.
Yeah, this thing.
We'll show the code first.
Yeah, so let's look at the code. So we've got so we're just going to show now using this from the .NET claim. We're going to show uploading a file. So we've got a sample here where, again, right now this only works with the channel type, which is, again, a new type in .NET Core 2.1. We are looking at, when we actually ship this feature, it would probably also support things like sending a stream, because a stream is really just a series of bytes anyway.
And so this is sort of a hack to do it.
Right, this is kind of emulating that. We open a file using a file stream.
Here's a file stream.
Yep, we read chunks out of it. And then we write each of those chunks to the channel writer, which means they appear on the server. And we can scroll over
back on the server side, we have the upload file here, and this takes in the channel reader. And then for each one, it just writes it to the output file. Yeah,
and this is another example of where you can pass in a channel, but also standard parameters like a string, etc. So
okay.
How do I snap this?
We can just run this one like this, but we'll snap it in the next one. So here, the sample's going to run, and if all goes well, it's got to compile everything, but it's going to...
Oh, wait, we should open up the server first, right?
You're just showing off your power line.
Oh, yeah,
that's what that's about.
All right. Whoa. We're loading this image here is the important part.
So, all right, so it's finished uploading. You see it's writing all those 5 KB chunks to the server. That was uploading our SignalR architecture diagram image that this image tag was referencing. Because it wasn't there yet, the link was broken. But now, if we refresh it, it should be there. Yeah, so now we've got the SignalR architecture diagram uploaded. Nice. Yeah, very simple. I mean, it doesn't directly support streams right now, but the amount of code needed to convert a stream into a channel,
it's like 20 lines.
It's not much. And I expect when we have this as an actual feature in the product, you'll be able to just pass a file stream in, and we will handle it for you. There's a bit of stuff to work out there around like when do we dispose the stream, how do we clean that up, but we can probably figure those things out.
Now, is there any kind of do spans fit into this somehow?
Well, not really directly. I mean, spans are just, you could send a channel of memory of byte, I think, is what you would send. Memory is memory and span are kind of a pair, and span is like only for working with a section of data within a single synchronous piece of code. Memory is the thing you can like store and throw around.
Right. Okay.
So yeah, I mean, they fit in, but only as much as they're a carrier for any kind of collection of data. Of course, under the covers, SignalR is using span and pipelines to do all of its sort of management, but
all the magic.
Yeah. And a couple of questions I note from the chat about like, can the client be sent anything from the server while it's in the middle of sending data to the server? Yes. That's one of the really nice features of this, is that if you were sending a huge file in a single message, then while that file is transferring, while that message is being sent to the server, you can't send anything else. The connection is taken up by that.
And if you do this and you do it in chunks, so you can be send chunk, and then you can make some other invocation that you want to make, and the server can give you the return value for that. And then you can keep on sending the stream items like one by one in the background.
Yeah,
and so
that seems like one of the most compelling features to me. Like that you're not kind of waiting for anything, that you're able to do this like two-way transport.
Yeah.
So, wow.
Yeah, you can interleave them. You can have multiple streams. You can have multiple different invocations with each with a stream. And as we got a demo to show here, you can have multiple streams in a single invocation as well. So I will sort of walk through what we've got with this
So here's this. This is the score tracker example, and the idea of this is that there's like two players playing some sort of game, and they each. So here's the game logic, and each round they score a random number between -2 and 10. So this is a game that requires like a lot of strategy. And so up here we make 2 channels, one for player 1, one for player 2, and then we just launch the game loop in a background thread. This is all in the client. And so these 2 channels, this loop will it'll generate the random score, and it'll just drop it into the channel. And then we await the score tracker function on the server, and we pass it the channel here, and we pass it the channel here as parameters. And when we go over here to the server, we see the score tracker function takes 2 channel readers. And what it does is score starts at 0, and it just reads the items that come in. And then if the score goes above 25 for either player, then the function here returns and says player 1 wins or player 2 wins.
And one of the nice things here is, on the server, we're spinning up these 2 loops, one for each player, and we're using await when any, which means that what will happen is as soon as one of the players hits 25, this task will complete, and we'll know that the task we get back is the winning player because it was the first one to reach 25.
And the interesting thing is that if you look here in the client code, the only exit condition for the game is the cancellation token, and this happens after the server returns. So what this is basically saying is, here, start up this loop on the client, just send data, send data, send data, and then in another thread, the server will say, hey, that's enough data, I'm good. And then you know to stop sending it.
Yeah, and I actually noticed there was a question about exactly this in the chat, and I was kind of waiting for this example. This is an example where the client isn't, the server is able to say, stop, I'm done, I don't need any more data. Whereas in the previous example for the file upload, the client was the one saying, this stream is now complete. Now the server is doing that by simply returning from its invocation. It says, I don't need any more data. The client can keep sending it data, and it'll just ignore it. And then in our code, we have that cancellation token that says, well, when the server says we're done, let's just stop it. Right. So now this one we will snap.
I switched the thing.
We'll swap that over there and that over there, and we'll do. I just shut down the server. I hit the wrong thing. Let's start that up again. I meant to do this. Clear this out so that we don't have extra text in the way. Too many screens. Yeah, and so we'll see both the server and the client will write out as they're getting it. That error in the background's fine. That's not a problem. You see the connection coming in, and then you see these scores coming in, and eventually one of them will hit 25. I hope. If we end up in a loop here, oh, there we go.
There we go.
And you see on the server side, you can see the scores as they built up, and then player 1 got to 26, and it returned. And if we run it again,
it's because player 2 kept getting -1s.
Yeah.
Yeah, there's penalties in this game.
Yeah.
points off if you mess up. And so this time player 2 wins. Look at that.
It's perfectly random, 50-50. You know, yeah.
Wow, this should be the new random number implementation.
Yeah, so that's kind of what we had for demos. The idea of this feature is to allow you to stream that data, any data that comes over time or is too large to go in one chunk, to let you stream it into to method invocations and sort of let you. It gives you that. I mean, pipelines is the hot new thing right now. And channels are kind of like pipelines, but instead of bytes, they're for objects, right? So you have one end that you write to it, one end you read from it. And what this is doing is letting you, now you can have those channels span 2 different processes. You can have, remote channels basically, and let you kind of write data across the wire that way. So.
Okay. So you said this is early on. This is not like a 2.2 thing. This is if people want to play with it, is it out in a repo that they can take a look at?
It's gonna be merged hopefully in 30 minutes.
Maybe not 30 minutes, but
right.
Today or tomorrow, yeah, we're hoping to merge it in. We're currently working towards this in the branch for ASP.NET Core 3.0. Mostly just because 2.2 is already kind of planned out, and this was kind of a project idea that we had, and we're still kind of playing around with it. I'll have to look into what we can do as far as like a package maybe people could use. We want to be extra careful because it's going to be a prototype. We want to make sure it's very clear that it's prototype. But I don't see a huge problem with us trying to find a way to at least give you some idea of how you can try it out. At the very least, you can clone the repo, you can build it, and there's DLLs you can reference. But yeah, we want to try and get this. We're happy for people to sort of check it out and see what it's like, but we're not 100% sure where we're going to ship it yet, except that we're pretty confident it's not going to be in 2.2. So.
Okay. So is this something where, like, feature-wise, this is all pretty like it does a pretty set like thing, and you don't really need any kind of input as to I wish it did this or that, or is it kind of something where you're interested in, like, are there some decisions that the community could like weigh in on or whatever?
Talk about this thing.
Yeah, we definitely need some feedback, I think, on this. And there are also some major limitations, like Dylan was just mentioning. Right now, those channel readers that you send, they have to be the parameter. They can't be put inside a list. You can't have a channel reader inside an object or a channel reader inside an array. And it's things like trying to figure out what kinds of objects do you want to be able to send this way? We know channel is the primitive we're going to use. We think we know we want to do stream. In theory,
like the IAsync enumerable.
Right. One of the things coming is IAsync enumerable, and we're probably going to want to support that as well. And also just like we want to see how people use it, right? A lot of what we do is we come up with an idea and we think it's useful, and we need to know if people actually want to use it and how they want to use it. So that's one of the reasons why I think we're not going to get it in for 2.2 is that we really want to have a chance for people to try it out.
So like if everyone ends up using this for file uploads, then we'll make like a nice upload this file function. But if everyone uses it for like tracking scores in multiplayer games. Oh, another cool thing you can do is that because you can get the channels onto the server, then once the channel's on the server, in the function somehow, you can take that channel and you can bring it anywhere else on the server. So you can have like a connect player function in a game or something, and that player will pass a channel to the server, and the server can take that channel and move it anywhere else and like put it in like a lookup dictionary or like put it in some singleton object, and then like return, it's like, yeah, we're good, we stored your channel. And then the client, anytime it writes to that channel, it can like write like the inputs for like a game that you're playing to that channel, and then those will pop out and the server can use them like later. And so this is a way you can do some like cool architecture things.
Wow. Okay. So it abstracts that away and lets you kind of move it around, like you're saying. How do I get, if let's say I've squirreled away a channel, how do I know that something's writing to it? Am I just watching for events on it, or?
Yeah, you have to have a loop that pulls from it. And so Go has that whatever thing that lets you select.
Yeah. So the channels API is something that they designed in CoreFXL like last release cycle, and it's basically there's two sort of core parts to it. On the read side, you saw with these two loops that you wait for items to be available, and that's an async thing. That's a task, and that task completes when new items are available.
And then while items aren't available, you just read from it synchronously.
Right. So you'd basically be setting up a background sort of polling loop, but because your background loop would be using async await, it's not like you'd actually be polling. You'd just be waiting. So it's kind of like an event, but it's not an event. It's like events using await. It's kind of the equivalent.
And if you were doing this game example, you don't necessarily, like your polling loop can already be your game loop. It's like every tick in the game, just go and check and see if anyone has new instructions for me, and then do those instructions and then repeat the loop.
Yeah.
Okay. And that inner loop where I'm looping through and reading things out, that's determined by how the client sent them up, right? If the client sent them up as 4 different chunks of things, I'm going to iterate 4 times through that.
Yeah. They don't stick together.
Yeah. We don't do anything to kind of and like the reason there's 2 loops, I can jump quickly back to that code. That's an interesting. I don't know how much Damien's talked about channels before, but we can do a quick jump into how channels work.
Yeah.
Yeah, there's these two loops. I think my screen should be sharing again. There's two loops. There's a outer loop here. So the outer loop is saying wait to read async. And so this is where the asynchronous logic is. So if there's no items available, your code will be blocked at this line 66 waiting for items to become available. Once items are available, we then we say while try read, get that item out, and this will run as fast as it can, grabbing all the items that are currently available until it runs out of items. So if the client sends 10 items and then goes to sleep and then sends 10 more items, then your inner loop is going to run 10 times and then pause on your
back to waiting.
It's going to go back to waiting, and then your inner loop is going to run 10 more times. There's also a slightly simpler API. Like if you really want to get the simpler code, you can go reader.read async, and that'll just give you an item if one's available. And if there isn't one, it'll just block. But this kind of lets you avoid going async until you actually know there's no data available.
Okay.
Yeah.
Let me see. Let's look at questions here. Bruno is asking, can you guys expand on the server-side routing? Can one use this similar to the Vertex event bus? I honestly don't know what that's talking about.
Yeah, I'm not super familiar with the Vertex event bus, but effectively, we're just tagging every time you. Yeah, you can actually go to
Stream Tracker.
Yeah,
so this is where most of the routing happens, and so how this works under the covers is that when you
go ahead, keep explaining.
So when you put a channel in as a top level parameter on the client, what the client ends up doing is replacing that parameter with a JSON object that says like, hi, I'm a stream placeholder and my ID is like 14. And then when you end up, so see here on the screen, it says item Z stream ID 1.
Yeah.
And so when it sent the invocation, it said, hi, I'm a new stream, my ID is 1. And then when you receive a stream data message, it'll say, hi, my stream ID is 1. And then the stream tracker, which is here, it's basically just a glorified dictionary with this. Here's the dictionary, and it maps the IDs to the channels, basically.
So really what it comes down is we assign each stream an ID as it comes in, and the IDs are used to route things to the right place. So the kind of the routing that you control is that you can call you can call different methods with different streams. Like if you want to have a stream for a certain kind of event, then let's say you want to have a stream, let's say you're running like an IoT device and you want to have a stream of temperature readings and a stream of pressure readings, right? You could have a single method called, stream input, and it can take two parameters. It can take a string, which is the type of reading you're sending, and then the channel, which is the actual data. And so you could call it once with temperature and then a stream, or you could call it another time with pressure and then a stream. And we'll keep track of which stream was passed to which method. And so in your method on the server, you'll be able to look at the parameters and sort of see which data is coming in from which invocation.
And these IDs are per connection.
Yeah.
Okay, that makes sense. So like if it was a game, I would have each one be like per player or something.
Right. Yeah, exactly.
You can stop sharing.
Wow. Let me see. Okay.
There's a question about reconnection. How does this work with reconnection? So SignalR, ASP.NET Core SignalR does not support automatic reconnection so one thing ASP.NET SignalR would do is it could reconnect, and when it reconnected, it looked like it was the same connection to the server. ASP.NET Core SignalR doesn't do that. When you reconnect, you're a completely brand new connection. So if you have a stream going and then you get disconnected, the stream ends. However, this is something you can kind of build on top of that. You can build logic to say, again, if you imagine that your method that's receiving the stream takes a parameter that's, say, the user ID of the person sending the stream, or you're using the authentication system to sort of track which users, because SignalR allows a connection to be authenticated with a user using all the sort of ASP.NET Core authentication stuff. If you did that, then you can use when the user reconnects and they send you a stream again, you can look up that user and say, okay, well, this is the new stream for that user. So yeah, we don't really have an automatic reconnection recovery system, but that's kind of true across the framework. That's not unique to this streaming. We just don't have that behavior today in any of the rest of the framework.
Cool. I don't see any other questions, and I don't have any offhand. Is there more? We talked about where that it's going to be merged soon, and so people can watch the SignalR repo in the 3.0 branch if they want to start playing with this.
Yep.
And then as far as any kind of gathering feedback, should they just open an issue or on the SignalR repo? Or?
Opening issues in the SignalR repo is probably the best way to do it. Keeping in mind that this is early days, early prototype kind of stuff. We're not sure exactly where it's going to land, but we want to hear from you as we always do.
I've got one more question, which is earlier on, there was a question about video, and I will confess that over time, whenever we've talked about like, the ASP.NET stand-up, and it's like, man, why don't we just hook up send some video frames over, over SignalR? How hard could it be? But I know video is difficult on the web. Like, what are your thoughts on that? I see Dylan laughing every time video is mentioned. What are your thoughts?
Okay, so it's okay, so SignalR is not a video streaming thing, and there's a lot of like complex compression stuff that you need to be able to stream video effectively. If you really want to stream video through SignalR, you should probably take like a compression algorithm that already exists and have it, compress your thing like on the client, and then you can send those like compressed blocks or frames or whatever it outputs over, and then unpack it on the other end. But I think you actually need a video thing if you want to send video.
Yeah, it could certainly be used as like the transport layer. It's something David is in the chat right now.
It looks like he just volunteered to write a video compression channel.
So, that nothing ever goes wrong when David decides to write some random prototype. But as someone who's had to clean a few of those up. But I guess I would say it doesn't feel like that like SignalR can add a lot that other protocols can't do. I mean, over a WebSocket, it would be pretty quick. I don't know if I'd want to send video over like long polling. That would get pretty high latency and pretty laggy. But you know what? People can do what they want to do, and if people want to do video streaming, it could work.
You could pick a good video streaming thing, build it into SignalR.
Yeah. I will say
stream video.
Yeah, I will say that I think that SignalR could certainly do a lot of things for signaling around a video stream, like something like managing questions and chat systems. Like that's the kind of thing we see more often there. But yeah, I think someone says in the chat that file chunking is a far cry from video streaming, and that's kind of where it comes down to. It's one of many pieces you need to do video streaming, but yeah.
Okay, fair enough. Well, Damien's here, and like now we've got adult supervision. We should probably call it there, I think.
Yeah. Dylan, how was being an intern at Microsoft?
Being an intern at Microsoft? Oh boy, how nice of you to ask. It's been really good because I get to come into work, I get to write code, and also we have like intern parties. We go into a party with other interns.
Yeah, we have pretty good intern program. Yeah. They have a lot more fun than I think the full-time engineers do. I want to be an intern again.
What was most surprising to you about the internship? Like what was different than you expected?
I'd say from like a technical perspective, working on something with so much architecture and like so many layers, and having to see, because like the stuff I've worked on before, it's all been like only like maybe like 2 or 3 layers. And you're like, all right, I can like do stuff in here and like move stuff around. And then you go into SignalR and there's like 7 or 8 layers, it feels like. And you have to like sneak stuff around all sorts of corners. And it's like a different way to think about like how do you like build an architecture and like how do you like scale systems. Oh, and then also async stuff.
Yeah.
Like that's all super new and exciting.
I was gonna say, I think we threw Dylan into the fire a little bit with this, because SignalR is not a simple, linear, easy to understand piece of code. It's a lot of complicated background loops, and he did pretty great with it, but learned a lot, I think.
Cool.
Yeah.
Are you ready for the dramatic zoom out?
I think so.
Yep.
Hang on.
All right. Ready.
All right.
3, 2, 1.
Bye.
Dramatic zoom out. It's kind of slow today, but pretty dramatic.